Hello guys, and welcome back to our YouTube channel. In this video, we are going to solve a past GCE question, that is GCE Advanced Level June 2016. So the question says, given the matrices M and N, where M is the matrix and N is another matrix, so we should find the matrix product Mn and Nm, and we should find the inverse of M. So let's start with a solution. So let's take the first one, Mn. So Mn is just the product of the matrix M and N. So we have this matrix M times the matrix N, which is minus 1, 0, 1, 5, 0, minus 2, 6, 3, minus 3. So in matrix multiplication, we multiply rows by columns. So let's start with our multiplication. So we have 2 times minus 1 plus 1 times 5 plus 0 times 6. We go to the next. 2 times 0 plus 1 times 0 plus 0 times 3. We go to the next. We are still on the first row of the first matrix. Let's go. 2 times 1 plus 1 times minus 2 plus 0 times minus 3. Now let us go. Let's go to the second row. This row, we have 1 times minus 1 minus 1 times 5 plus 1 times 6. I have minus 1 here because it's minus 1 there. If it was just 1, it could have been a plus sign. We'll go to the next. 1 times 0 plus 0 times minus 1 plus 1 times 3. The next, 1 times 1 minus 1 times minus 2 plus 1 times minus 3. We go to the next. 5 times minus 1 plus 1 times 5 plus 0 times 6. The next, 5 times 0 plus 1 times 0 plus 0 times 3. Go to the next. 5 times 1 plus 1 times minus 2 plus 0 times minus 3. So we do our simplification. Minus 2 plus 5 plus 0. 0 plus 0 plus 0. 2 minus 2 plus 0. Minus 1 minus 5 plus 6. 0 plus 0 plus 3. 1 plus 2 minus 3. Minus 5 plus 5 plus 0. 0 plus 0 plus 0 again. 5 minus 2 plus 0. Now let's simplify this. So we have minus 2 plus 5. We have 0 here. We have 2 minus 2. Minus 1 minus 5 is minus 6 plus 6. 0 plus 3. 3 minus 3. Minus 5 plus 5. 0 and 5 minus 2. So finally we have 3 0, 0, 0, 3, 0, 0, 0, 3. So this is our matrix M, N. Okay, now we have found M, N. Let's find N, M. So we take the matrix N, 6, 3 minus 3 times M, 2, 1, 0, 1 minus 1, 1, 5, 1, 0. So let's multiply again, rows by columns. So minus 1 times 2 plus 0 times 1 plus 1 times 5 minus 1 times 1 plus 0 times minus 1 plus 1 times 1 minus 1 times 0 plus 1 times 0 plus 1 times 0. We take the next row, 5 times 2 plus 0 times 1 plus 5 times minus 2. 5 times 1 plus 0 times minus 1 plus 1 times minus 2. 5 times 0 plus 1 times 0 plus 0 times minus 2. 2 times 6 plus 1 times 3 plus 5 times minus 3. 1 times 6 plus 3 times minus 1 plus 1 times 3. 1 times minus 3, sorry. So 3 times minus 1 plus 1 times minus 3. 6 times 0 plus 3 times 1 plus 0 times minus 3. Okay, so let's simplify this. So we open our brackets. So it's minus 2 plus 0 plus 5 minus 1 plus 0 plus 1, 0 plus 0 plus 0. Okay, 10 plus 0 minus 10, 5 plus 0 minus 2, 0 plus 0 plus 0, 12 plus 3 minus 15, 6 minus 3 minus 3, and 0 plus 3 plus 0. Okay, so let's simplify it again. So this is minus 2 plus 5 minus 1 plus 1, 0, 10 minus 10, 5 minus 2, 0. So 12 plus 3, 15 minus 15, 6 minus 6, and 0 plus 3. So we have 3 here, we have 0, we have 0, we have 0, 3, 0, 0, 0, and 3. And this is the same thing as our so this is Okay, so hence we should find M inverse. So let me write the matrix M. So that is the first part. We have found we have found So now let's find M inverse. We write our formula, the determinant of M times the adjoint of M. So let me write back our matrix M. 2 1 0 1 minus 1 1 5 1 0. So let's find the determinant. Write our signs: plus minus plus minus plus minus plus minus plus. I choose the first row. It has a 0. We take the first number 2. We delete its rows and columns. What are we left with? Minus 1 1 1 0. The next minus 1. Delete its row, its column. What are we left with? 1 1 5 0. Take the next 0. We just allow it as 0. We don't need to look for its 2 by 2 matrix. So we have plus 2 into. Now 0 times minus 1 times 1 into minus 1 1 times 0 minus 5 times 1. We simplify. So this is 0 minus 1, 0 minus 5. So we have plus 2 into minus 1 into minus 5. So this is minus 2 plus 5, which is 3. So our determinant of M, let me just erase it. So our determinant of M is 3. So let's find the adjoint. We write the matrix 4 times. So 2 1 0 1 minus 1 1 5 1 0 again 2 1 0 1 minus 1 1 5 1 0. Now the third time 2 1 0 1 minus 1 1 5 1 0 2 1 0 1 minus 1 1 5 1 0. Now we remove the outer numbers. We are left with minus 1 1 1 minus 1 1 0 5 1 1 0 2 1 minus 1 1 1 minus 1. Okay, so we group them 2 by 2s. So now we are looking for the matrix of cofactor. We take the first 2 by 2. Zero times minus 1 times 1. We take the next 5 times 1 minus 1 times 0. We take the next 1 times 1 minus 5 times minus 1. Take the next 1 times 0 minus 1 times 0. The next 2 times 0 minus 5 times 0. The next 1 times 5 minus 2 times 1. We take the next. 1 times 1 minus 0 times minus 1. The next. 0 times 1 minus 1 times 2. And the last one, 2 times minus 1 minus 1 times 1. So now we simplify. So 0 minus 1, 5 minus 0, 1 plus 5, 0 minus 0, 0 minus 0, 5 minus 2, 1 plus 0, 0 minus 2, minus 2 minus 1. So we have minus 1, 5, 6, 0, 0, 3, 1, minus 2, and minus 3. So this is our cofactor matrix. So now we find the adjoint from here. So the adjoint is just the transpose of the matrix of cofactor. So it is just the transpose of this matrix. So now let's take the transpose of the matrix. The row becomes the column. The first row becomes the first column. Minus 1, 5, 6. The second row becomes the second column. 0, 0, 3. And the third row becomes the third column. 1, minus 2, minus 3. So this finally is our adjoint of M. And now the inverse of M, 1 on the determinant which was 3, or determinant of M was 3, now times the matrix which is the adjoint, which is minus 1, 0, 1, 5, 0, minus 2, 6, 3, minus 3. And I'll just leave it like that. And that is the last question. That's all for this question. So thanks for watching this video, and I'll see you guys in the next video.